Archimedes Principle. Are you aware of the fact that some objects float on water while others sink? Let's look at a beach ball. Do you know what makes a beach ball float on water? It is the upward force exerted by water that makes the beach ball float. To experience this force, try pushing a beach ball underwater. You will feel an upward force that makes it difficult to push the beach ball down. When you release the beach ball, it bounces back to the surface. What happens here is that the force you apply onto the beach ball acts in the downward direction, pushing the beach ball down. But the water exerts an upward force onto the beach ball, pushing it up. This upward force exerted by water on the beach ball is known as upthrust or buoyant force. Have you ever wondered why a teeny pebble sinks while a massive cruise ship floats on water? Let's see. Although the pebble looks tiny, it is solid and compact and occupies very little volume. There's more mass per unit volume within it as compared to water. In other words, its density is greater than the water. Thus, the upthrust exerted by water on the pebble is less than the weight of the pebble, causing it to sink. A ship is hollow, filled with the air and occupies more volume. There's less mass per unit volume within it as compared to water. In short, its overall density is less than water. Thus, the upthrust exerted by water on the ship is greater than the weight of the ship, letting it float. From these examples, we can conclude that the magnitude of the buoyant force depends on the volume V of the immersed body, the density ρ of the fluid, and the acceleration due to gravity. Thus, upthrust or buoyant force is equal to ρVg.
An object generally experiences a loss of weight in water due to buoyant force, and this force is equal to the weight of water displaced by the object. This is explained by the law of buoyancy, also known as the Archimedes Principle, named after the Greek scientist who discovered this law. Archimedes Principle states that when an object is immersed in a liquid, the apparent loss of weight of an object is equal to the upthrust, and this is also equal to the weight of the liquid displaced. An object will weigh lighter when submerged in a fluid than when it is outside. Say, the weight of an object outside is 10 kilos. When you submerge the object in a fluid, you will observe a decrease in the weight of the object to, say, 8 kilos. You will also notice an increase in the level of the fluid. This is different in the fluid level volume will equal to the loss in weight of the object when submerged in the fluid. The loss in weight of the object in this case is given by the weight of the object when outside minus its weight when immersed in the fluid. So, the loss in weight of the object will equal the weight of the increased fluid. The weight of the increased fluid will in turn equal to the buoyant force experienced by the object. Thus, Archimedes' principle is verified. Today, there are many things that work based on the Archimedes principles. A few examples include the design in ships and submarines. Hydrometer is used to find the specific gravity of liquid, and lactometer is used to determine the purity of milk. Let's recap what you have learned about Archimedes' principles. The upward force exerted by a fluid is called upthrust or buoyant force. Buoyant force equal V rho G. Archimedes' principle states that when a body is partially or fully immersed in a fluid, it experiences an upward force that is equal to the weight that is displaced by it. Archimedes Principle is also known as the Law of Buoyancy.